Hey guys, Buildzoid here, and welcome to whatever this video is supposed to be. The issue with today's video is that this isn't finished yet. And you might be like, well, why are you making about a video before it's even finished? Because by the time it's finished, there's I don't know what I'm gonna do with it in terms of how I want to cover it in a video. So yeah, anyway, I guess we should first talk about what this is. So this is a EVGA GTX 1070 FTW that I picked up on eBay for about 60 quid, which is awfully cheap for a GTX 1070. And the reason it was 60 quid was because it was dead. Unsurprisingly, it was broken. It's a 1070 FTW. Basically, the problem with these cards is that EVGA got sent a whole bunch of faulty components from one of their suppliers. And so these cards all basically, it's pretty much inevitable that a lot of these cards will have the VRM fail in quite a spectacular manner where it just burns a great big hole into the PCB. Now, at the time that this whole thing was first getting into the news, that these 1070 FTW cards and also 1080 FTW cards, because those cards use the same PCB, when this was getting into the news, everybody was the initial reaction was oh, these are catching fire because the VRM cooling is really, really bad. So EVGA offered a thermal pad upgrade kit. The thermal pad upgrade kit doesn't do anything because it's faulty components. Those components will literally, these cards are liable to fail if you're on the desktop. It's not if you have a VRM that's underpowered and overheating, it'll blow up under load. These cards blow up under load, but they also blow up at idle. So it's just, yeah, the VRM on these is just unfortunately defective. Anyway, so eventually EVGA released the 1070 FTW2 and 1080 FTW2, where they changed component suppliers for the faulty part. So those later cards are completely safe; they don't use the same parts. But yeah, because of that, these are EVGA didn't replace all of these when this was a issue. They just sent out thermal pad upgrade kits. The thermal pad upgrade kits don't really do anything. This card had one of the thermal pad upgrade kits. Yeah, I tried to record the actual process of installing the e-power on there, but unfortunately that video sort of went off the rails because I had a bit of a headache at the start of recording, and by the end of recording it was so much of a headache that I couldn't finish the build, and I also couldn't really finish the video. So yeah, so that just went down. That was really unfortunate. What really frustrates me about that is that was the only footage that I have of the thermal pad kit being installed on the card. So you'll just, yeah. So that's I'm a bit annoyed by that because it's this is the second time I've had one of these dead FTW cards, because I also have a 1080 FTW with an also blown up VRM for the same reason. And I bought it for the same reason, because it's just if the nice thing about these is that the VRM is laid out in a way that it's very easy to replace the entire vCore VRM with the VRM of a different GPU or with a power board an e-power or something. In this case, we're using an HD7970 VRM. But anyway, the annoying thing is both of the cards that I've had that failed had the thermal pad upgrade kits, and I don't have, I never managed to record footage of hey, look, these thermal pad upgrade kits don't actually prevent the failure, because it's not about the operating temperature of the VRM. It's about the fact that the VRM on these cards just has dodgy components. I can't tell you which exact parts it is because of an NDA. I know exactly what's wrong with these, but I can't tell you, which is really unfortunate. But yeah, basically, but the neat thing is you can get these dead on eBay really, really cheap, and you're pretty much guaranteed to just have a VRM failure, which is relatively easy to fix if you're like me. So yeah, I really like these. So I picked so I have the 1080 FTW, now I have a 1070 FTW. As I mentioned, the VRM that I've put onto this is a HD7970 reference VRM. Yeah, which just I have a lot of dead AMD GPUs and a lot of dead HD7970s, and this is a good 6+1 phase VRM. The +1 is for memory. We're not using that here because the memory VRM on these cards is fine. It's just the vCore that blows up. Anyway, so that's what's on the card. In terms of the damage that was on the card, the back of the card literally looks like this. Yep. that right there. So yeah, that's what's wrong with the card. And yeah, so the like this isn't technically this isn't like an impossible level of damage to like clean up and replace the faulty components and that kind of like, well, actually on the front side of the card you're not replacing anything here, okay? You can clean up the hole in the PCB and like remove the short circuit, because the thing is, when a component fails this like this hard, it just burns through several layers and they're all shorted out. So you basically need to like grind away the entire area until the short circuit is removed. And like you could do that, but the thing is, the rest of the VRM is made of the same components that, caused this in the first place. So like, why would you want to keep using the VRM on one of these? Right? Like, this isn't even like a GTX 980 Ti situation where the VRM is just like underpowered for what it's trying to do. Like, this is just straight up not okay. Like, this just dies a lot. Anyway, so yeah, so the lazy solution to the issue, or I'd say the best solution to the issue, is you just replace the entire VRM, which is what I've done here. Now, you might be wondering about the heatsink. What's going on with that? The heatsink is off of a GTX 680, because I have a dead one. I have a lot of dead GPUs, so I have a lot of heatsinks. And yeah, this is a really convenient heatsink because it has reasonable like clearance against the card's PCB. It's not too long, so unfortunately, like, the funny thing is, this actually, like, I am using a PCIe slot riser right now, so I'm using one of these on this. But funnily enough, this is, like, with the riser installed, this is actually short enough that you can install it in some ATX motherboards. Like, if there's not any components directly under the PCIe slot, this actually fits on ATX motherboards, which is kind of cool. So it doesn't have to be on an ITX board, but I have this ITX board out because I have a different e-powered GPU where the heatsink was not as like, which I have a different heatsink on, and that one just isn't going to fit onto a motherboard whatsoever. Anyway, so yeah, as for the fan, that's a fan off of, actually, that's the fan on this is actually out of the RTX 2080 that's in my daily system, because the RTX 2080 that's in my daily system, also got it on eBay, and that thing had shot fan bearings on two of the two main fans. The fan bearings were just completely trashed. This fan, on the other hand, was fine, so I just kind of kept it in case I someday needed a random GPU fan. And, that's how that ended up there. That is literally held in place by just like self-tapping screws into the fin stack. So yeah, that's like, if you want to bolt fans to a random heatsink, self-tapping screws are your friend. As long as the fins aren't too loose, like, I probably wouldn't try to bolt the fan up into this area. Well, actually, you could probably still pull that off if you got a little bit, like, if you squished the fins together first and then tapped the screw into it, the fan would probably not come loose. But yeah, basically, if you can just self-tapping screw fans into heatsinks, if you want to attach random fans to heatsinks like this. You might be wondering, is this actually a viable cooling option? Not really. It's good enough that, like, I can run Firestrike on this. It'll finish benchmarks, which I'm really surprised by, because the HD7970 VRM in its current configuration defaults to a 1.05 volts, and there is V-droop because it's a reference HD797, actually reference AMD VRM, like AMD. So this is a sort of design, like, power delivery difference between NVIDIA and AMD GPUs. NVIDIA GPUs don't really have like a DC load line. They have an AC load line, so the idea behind having an AC load line is that the VRM doesn't fight transients too hard because it's going to lose. But a DC load line basically makes the VRM go with the flow, whereas an AC load line is kind of just like the VRM temporarily lets the voltage deviate on purpose. And you might be like, what's the point of having AC load line then if it doesn't help the voltage regulation? And it really doesn't. Like, voltage regulation on NVIDIA GPUs is absolutely horrendous. And the reasoning behind it is that NVIDIA, instead of trying to like get the voltage regulation like really dialed in, the card just clock stretches anytime there's a a voltage deviation that's like too big, the card will literally just like it just clock stretches. So the funny consequences of NVIDIA's approach to power delivery is that depending on what average, like depending on how good your voltage regulation is and what your average load voltage is, the same clocks lead to different performance. So this right now runs, but I would not be surprised, but I don't have a like good condition working 1070 to compare against. But I would not be surprised if this is currently underperforming for the clocks that it's running at, because it is running on very little voltage. Like under load, this is running at about 0.95 volts, which is way low. The voltage regulation is also not great. And so I suspect that the card is clock stretching like crazy, even though it's reporting like 2 gigahertz when it's actually running. And yeah, so that's kind of some background information on this thing. Now let's actually turn this on and mess around with it a bit. Also, like, because it's running on 0.95 volts, the heatsink doesn't really have to work very hard. So yeah, like this fan's not great. It doesn't really move a whole lot of air. But the thing is, this is just a really convenient fan to tap into the heatsink. It's not light. It's not super heavy. I didn't want to use like a case fan. Also, like strapping a case fan to the card was just awkward, and it's just like, yeah. So this works out. In the future, I might experiment with actually like putting two, because I have a bunch of random GPU fans. So I might look through my collection of random fans and probably try to get a second one up here so that the heatsink, like the cooling performance, is a bit better. It's actually a decent heatsink. It's got 4 heat pipes in it and like a really nice solid copper base. Fits a lot of GPUs. Anyway, let's turn it on. Right now I have the oscilloscope set up for single shot capture, so we can take a, well, you're not really going to see it up close, but you'll have some idea of what's going on when this turns on. There is a bit of a turn on spike transient. So yeah, that. It looks way worse than it really is, because the peak of this is only 1.21 volts. So the VRM in its current configuration is set to output 1.05 volts. So this right here, this is 1.21. This, once it levels off, that's 1.15. So, yeah, this is like, it looks way worse. Like, it looks really bad, but this is actually not really a big deal. Like, this isn't going to damage the card in any way, shape, or form. It's not ideal. It's not like this is not the cleanest power on transient I've ever seen. But considering that this VRM really isn't supposed to be attached to this card, and I also don't have forward voltage sense set up, like, this is very early stages of building the e-power onto there. Like, my eventual plan is I ideally want to move the power board to the back of the card. The thing is, getting good power delivery through the back of the PCB is, like, I'm not sure if that's actually going to work. So I want to run a whole bunch of, like, experiments with different like power delivery connection setups with the power board to the GPU, and see how that affects the voltage regulation. Also test like forward voltage sense, because currently the VRM is monitoring its output voltage at its like on itself. It's not monitoring it at the GPU core. So obviously that's well, basically we're adding more DC load line in a way, because the VRM is currently not typically a properly implemented VRM will be compensating for the power plane impedance somewhat. How much depends on your load line set, like how the control loop is set up and the load line and that kind of thing. But typically a VRM can totally compensate for power plane impedance. This currently does not account for the impedance of the power plane whatsoever, because it measures on the VRM, not at the GPU. So yeah, but like when it was still attached to a 7970, that VRM was regulating against the 7970 itself. Anyway, let's put the oscilloscope into run mode. So yeah, this is our idle voltage right now at 1.05 volts. Now, what's kind of neat about this VRM is this is off of a 7970, and the original VRM on this 1070 was a 10-phase VRM, which was a 5-phase with doublers, because back when 1070s were being produced, you couldn't actually get a proper 10-phase VRM controller. That wasn't really a thing. But even then, it is a 10 phase because if you take 5 phases and run them through doublers, you do get 10 out of phase phases. That's kind of the whole point of having doublers. Anyway, the funky thing about this VRM is that this is off of a HD 7970, and it has working phase shedding, which is kind of neat. Like, what's crazy about that is, so if we put the multimeter into frequency mode, right now I'm in the UK, so right now it's just picking up 50 hertz from the mains, but if we go up against the VRM here, wait, what? It should be reading 400 kilohertz. Oh, so we have like a sleep state for the VRM as well. So basically right now the VRM is sleeping, I think. We really should be measuring a higher... Yeah, so this phase currently is not turned on at all. Neither is this one, right? And that's kind of the neat thing is like most of the VR, like it has phase shedding. So the VRM actually dynamically turns phases on and off. Oh, there we go. So yeah, that phase just woke up. I'm not entirely sure why. Oh, okay. So if you're wondering what's happening when I do this and you see all that, like the line get fat on the oscilloscope, when you probe a switching voltage regulator with, you know, like a multimeter probe, which has a great big length of wire, the multimeter probe turns into a great big antenna and it radiates VRM switching noise into the environment. So that's what the oscilloscope is picking up. So also, if we have audio issues during this video, that's potentially why that's happening. But anyway, so yeah, that's the scope just picking up the switching noise from the VRM because it's being radiated by the oscilloscope, by the multimeter probe right now. But yeah, so you can see that. So that phase is switching at 360 kilohertz right now because the card is basically at idle. I'm just going to pull up GPU-Z and we're going to run the render test. We're also going to run Firestrike because, like, I would like to try get all, like, I haven't seen all of the phases on the VRM turn on yet, which I think is kind of neat because, like, this is a 6-phase off of a 7970, and it's just kind of neat to see that, like, this VRM, like, doesn't consider a 1070 a high enough power draw GPU to turn on all of the phases. I just think that's kind of neat because basically the way the phase shedding is set up, well, it depends on the VRM, but on this VRM, the way it seems to be set up is that for any given amount of current, it'll enable an extra phase. Like it has a per phase amount of current that it'll allow before it turns on another phase and another phase and another phase. So basically, if the GPU doesn't pull enough power, we only have one phase running, and if it's pulling more, like enough power, like if the in order to get all 6 phases running, like the GPU actually needs to pull a lot of power, which currently it won't do because we aren't really putting that much, like the VRM isn't outputting like full voltage for a 1070 at all. So yeah, but anyway, so let's go through. So right now, this phase is running 300 kilohertz, and this phase is not running at all. Yeah, no, that one's not, is it? No, that one's not running. So anyway, I'll start the render test. And yeah, that wakes that phase right up. So that's 500 kilohertz on that phase. Same on this bottom one. So now we're in 2-phase mode. I think maybe phase 3 might have woken up. Yeah, phase 3 woke up. Phase 4. Yeah, so phase 4 woke up, but 6... 6 is, yeah, 6 is still asleep. I mean, actually, that's 5. 5 is asleep. And 6 is also asleep. So, anyway, that's kind of neat. Also, we do have V-droop on this, as I mentioned. And it is not like, because you just saw the voltage dip on, like the voltage level on the scope dip down when GPU-Z load started. But that's actually not from the, like some of that voltage dip is from the impedance of the connections from the power board to the PCB, and then also the impedance of the PCB itself. But the thing is, even if we look at where the VRM is regulating, right? So right now we're at 1.05 volts, come on. Or 1.04. If I start the render test. So yeah, there's a bunch of V-droop. on the card. So, yeah, anyway, we're going to pull this up, and now let's try run some Firestrike. And actually, we'll try overclock the card a little bit, because I haven't tried to overclock it at all. And I'm kind of wondering, so, like, right now, with default settings, this card actually goes up to just under 2 gigahertz. So we're going to, like, I don't have voltage control right now. Also, what's kind of funny is we don't have, well, what surprised me is I didn't have to do anything about the power monitoring, because obviously, when you replace the VRM like I did here, right, like, there's, like, the only power going into the GPU PCB itself right now, at least for like 12 volts, is the memory power. And so I really thought I'd have to deal with the current sensing, because NVIDIA GPUs typically get very upset if they don't detect enough current draw. But for whatever reason, I didn't have to do anything. So that's really cool. That this was super easy to build. Like, the only thing you really need to do is there's like a, well, we'll cover this in a future video, but there's basically just like a little power jumper that you need to do, because otherwise the card doesn't run. Anyway, so first we're going to do like an all stock run, and also on this Windows install, for some reason, like all of the, like, I think most people would want to see Time Spy, but Time Spy is currently broken. Or actually, maybe Time Spy is crashing because the voltage regulation's not good enough. That's also a possibility. Oh, I guess I should try to keep the oscilloscope visible. Oh, there's not really any good way to do that. Oh, no. Maybe like this? Yeah. Okay, let's do it like this. Actually, let's also have GPU-Z open. I'm not sure. It's possible that, like, it is possible that the voltage regulation is so bad that Time Spy won't run, but Firestrike will. Though, actually, I think I tried underclocking the card, and that still didn't fix it. So let's see if I can get Time Spy to run. I think it's broken right now. So we're going to drop the core clock all the way down. And we're going to try run Time Spy and see what happens. Unfortunately, trying to change the... Yeah, no, Time Spy is actually just straight up broken. Okay, so cool. So that's not like a voltage regulation problem. That's just Time Spy's broken. So we're going to start at +0, and we're going to run Firestrike, which, like, I know most people would prefer Time Spy, but, like, Firestrike's my favorite benchmark, because that's sort of the benchmark that was relevant when I got into PC building. So anyway, here goes Firestrike. I gotta say, I'm actually kind of impressed with the voltage regulation, because it's not that bad. Like, it's not great. And also, it's a 1070. It doesn't pull that much power, but this is really not that terrible, because this is only 200 millivolts peak to peak. Which is, it's not great. Also, there is coil line, but yeah, 200 millivolts peak to peak is like there are NVIDIA GPUs that it's like on their own VRM will have worse peak to peak than this, like 300 millivolts. Admittedly, they pull more power than a 1070 does, so that might have something to do with it. But yeah, that is just kind of a funny thing, is like this actually isn't doing that badly in terms of voltage regulation, even though it's like very much not finished and the connections aren't great. Trying to see if phase 5 will turn on. Nope, phase 5 is still not turning on. There's maybe a possibility that the phase shedding isn't working properly for the... Like, I'm kind of wondering if maybe the top 2 phases aren't broken for some reason, because that's the thing about the HD7970 VRM, which is kind of annoying, is that the HD7970 VRM uses a CHL8228G, and that chip has no public information available about it. So it's really, like, if you have a CHL8228G on a GPU and it's misbehaving for some reason, you're just kind of screwed. We don't need to run the physics test. Yeah, so 18,000 points. I think that's right for a 1070. I'm going to quickly check hardware bot. Like, it's for a stock, I feel like it's a bit low. Because, like, you can get RX 580s to... Oh, wait, that's without tessellation. So, no, that might be correct. That might be correct. In which case, like, that's pretty cool. Because, yeah, the card's technically undervolted right now, right? Like, that's... yeah. Anyway, 1070 Fire Strike. I don't want the top score, because obviously that's... Yeah, the current top score for Fire Strike is 23,000 points overall, with the GPU score being 24,000 points, so... Yeah, but that card was on liquid nitrogen doing 2.5 gigahertz. So, oh man, that's going to be really hard. Because that's like the main reason I've got a 1070 is I want to run it on LN2. Because 10 series GPUs on LN2 are really, like, they're really well behaved, and they're really fun. At least if you get lucky and you get a card that doesn't have a cold bug. But yeah. So it's going to be really hard. I'm trying to find a card that's running like 2 gigahertz-ish so that I'm not comparing against some crazy overclock. Here we have one. Yeah, okay, 18,000 points. I mean, it does seem a bit low, but I am looking at hardware bot results, so these probably aren't stock. So, yeah, it seems to be behaving just fine. So now let's see if we can overclock at all. Actually, that was a plus 14. What did the sensors pick up? 19. Okay. Okay, let's go. I don't think plus 100 is a good idea. Let's do plus 59. Because the thing is, this card has a really high stock boost, right? 1999 is quite a lot of boost to begin with. Also, max temperature during that run was 58. Yeah. The cooling situation is definitely suboptimal. Mind you, that's with the little fan maxed out. The thing is, that fan just doesn't move that much air. It really doesn't. Like, it's just enough. Like, honestly, we're probably, like, right now, we're basically relying on the mass of the heatsink more so than the, actually, we might see frame skipping if we overclock it too much. So that's a sort of neat thing with Pascal GPUs on the oscilloscope, is if you push them too far, you'll actually see, like, the noise pattern cut out temporarily whenever the card doesn't render a frame. Though I think I've primarily encountered that on liquid nitrogen, so at ambient we might not see it. But that is a thing that, like, the oscilloscope, like, having the oscilloscope hooked up is really neat for 10 series cards, because you can basically see, like, performance issues due to instability before they show up in the score. Because, like, if you're seeing frame skips just constantly, because basically a frame skip is the card decides not to render a frame whatsoever. Yeah, so that's pretty cool, in my opinion, being able to see that. Anyway, also we could zoom in a bit on this. So, unfortunately, like, without running it with VSync, it's impossible to tell, like, what's actually going on right now. Yeah, but like, each of the, like, you can actually count the frame rate from basically the number of spikes you have downwards or upwards. Well, it depends on the VRM configuration, but yeah, you can count the frame rate from this. The oscilloscope's built-in frequency counter won't do it because it's too noisy, but, like, you can manually count the FPS from the noise pattern. Anyway, so we'll escape out of that, and that actually ran at 2025. So that's pretty cool. So it can overclock. That is rather surprising. Let's just go for plus 100. Also, I'm just going to max everything. Right, the core voltage slider shouldn't do anything right now. So yeah, we're just going to max everything. How much memory? You know what? Actually, there's a lazy way to do the memory overclock. We're just going to run the render test. Okay, plus 500 memory. Wait, maybe I should have just looked at the hardware bot results and copied someone else. Wait, these things can do 2400 on the memory? Damn. Okay, well, let's try plus 600 then. The thing is, it's on the stock memory VRM, so we shouldn't have memory issues. Yeah, that runs just fine. So that's 2100 core right now. If this is still stable, I'm going to be very surprised. Also, I bet the card has to be clock stretching like crazy. Also, what did we get? 18375. Well, I didn't really change the clocks that much, so that makes sense. There's a chance it might, like, if the card was memory bottlenecked before, then right now it's going to be mega unstable. It might also just crash because of the core clock. Like, this is not, you know, good overclock. Like, if you're trying to, this is not good overclocking practices, what I'm doing here. Changing two values at the same time and just kind of winging it. Still running, though. I'm really surprised that this still works. It can actually overclock. Now, admittedly, with Pascal GPUs, if you like intentionally feed them like 0.7 volts, you can do some very, very weird things with the core clock. So the fact that we're undervolted might actually be throwing, like, it is definitely throwing off the results. Then again, depending on how bad the stock voltage regulation is, our minimum voltages might not be that low. Yeah, so there's like a bunch of testing I want to do with the card. Okay, well now we're getting like 200 millivolts peak to 220 millivolts peak to peak, because as you increase the core clock, the power consumption goes up. So you know the transients get worse and worse and worse. But like it runs to my great, like it overclocks and it runs, which is honestly kind of like it's kind of surprising. I have a sneaking suspicion the scores are not going to be lining up with where they're supposed to be, but eh. Yeah. Like I really need to set up voltage control on this, because basically if you do have too little voltage, like your score will be lower than it should be just because of the voltage. So that ran a 2075 according to GPU-Z, 19,525 points. You know, it's not spectacular. Honestly, it's probably pretty. Yeah, I think this is kind of low for the clocks. This is definitely low for the clocks that it's reporting. So anyway, we're gonna try raise the core clock to plus 148. If we hit like 2.2 gigahertz, it's definitely clock stretching like crazy. Unfortunately, we can't see that on the oscilloscope. Like you can see it if it's straight up skipping frames due to instability. You can see that on the oscilloscope. Clock stretching is completely invisible as far as I can. Like I'm not aware of any way to check clock. Well, actually, we could use hardware info for that. Yeah. I think hardware info actually has a effective clock monitoring thing for NVIDIA GPUs. I think I'm starting to see some frame skips. There's like certain there was a couple of irregularities in the noise pattern, which could, yeah, I think I just saw another one. It might have been skipping frames. The thing is, it's running at such high FPS, it's really hard to catch the frame skips. I can't trigger on them because, you know, like the most of it is just noise. So it's like, how do you trigger on the part that isn't noise? Yeah, it looked like there was a few frame skips at this point. I'm surprised that it's only getting 200 millivolts peak to peak. Also, it's only running at like 0.93 volts, so like it's way down on voltage. Yeah. It is actually way down on voltage. I bet if we ran it at 1 volt, it wouldn't be stable and it would score better. So yeah, I have like a whole bunch of testing that I still need to do with this card. The final goal is to move ideally I want to move the VRM to the back so that I can use the original FTW heatsink, because I think the heatsink that these cards come with it's a really good looking heatsink. Yeah, like these are really, really good looking cards. So I'd love to be able to use the stock heatsink, and the only way I can do that is if I move the power board to the back. Because unfortunately, like, yeah, no, I'm not fixing the VRM. There's no point. Oh, we're running full Fire Strike. Actually, no, we won't. 19, yeah, it is. We're at 2113 on the core clock right now. It is clock stretching. It is definitely clock stretching like mad. Let's try plus 700 on the memory. This card has Micron. Actually, Micron GDDR5, like, there's like a, yeah, Micron GDDR5. Some of it's like really good. Some of it's also not that great, but there's some really good Micron GDDR5 out there. So hopefully that's what this has. Anyway, let's run Fire Strike again. I'm certain that this thing is clock stretching like crazy, because it should be crashing at this point. Also, it's really not scoring very well. Oh, it finally crashed. Yeah, and that was 2176. Yeah, 2176. So it won't run 2176. Cool. Go down to plus 148. But yeah, so that's my e-powered GTX 1070. Also, what was the max temperature? So during that, we maxed out at like 60 degrees Celsius. I wasn't really letting it cool down very much in between runs. How's the VRM doing? It's not even hot. Makes like that explains why it's only not why it's only running 4 phases at a time right now. I really hope I get it to the point that it actually turns on all of the phases. But yeah, so that's it. I want to do a video actually covering how to build a power board out of the MSI HD7970s, because this is a really easy e-power. And it's also really convenient. Like, there's certain GPUs that it's like easy to get the VRM to turn on. Like a lot of a lot of RX 480 VRMs are super easy. You can just cut it off because it's by the PCIe slot. So you just cut it and you feed 3.3 volts through the PCIe slot into the board, and everything, like, it just runs. It's super easy to get those VRMs to fire up. The problem with those VRMs is that their layout doesn't really give you any good way to connect your ground and voltage is easy. Like, connecting vCore, like the vCore of the output of the VRM to the like vCore power plane of your target GPU, or like you technically could do this to a motherboard. I don't know why you'd want to do this to a motherboard, but you could. So like it's really easy to connect like VRM output to the vCore of a GPU or motherboard, but the ground connection on RX 480 VRMs is a nightmare. There's just no good exposed ground connections to the internal ground plane of that VRM. This, on the other hand, has a really convenient like pattern of ground and vCore fills on the back. That's why you can that's why this isn't why the power connections aren't like a solid strip of copper. It's like individual strips. That is alternating, like on the back of the card, it's basically alternating ground, vCore, ground, vCore, ground, vCore. So this is super convenient, like for connecting the board to stuff. Whereas there's a lot of GPUs where you're just not going to have this like easily accessible ground connection. And that makes life very difficult. So yeah, these like reference 7970 VRMs are super convenient. I've tried also to build an e-power out of a 7970 Vapor X VRM, and for whatever reason I can't get that one to turn on, and it's been really frustrating me. But these like MSI 7970 VRMs, and actually probably the like straight up reference 7970 VRM, should be super easy to build into an e-power. The downside with the the full like regular reference 7970 VRM is that that's just a 5-phase, not a 6. So MSI actually slightly improved the VRM for their like 7970 twin Frozer cards. Anyway, I have 2 of these cards, so I actually have a second one that I want to. I don't think I'm going to detail the actual like. I'm not going to show, I think, the actual process, but I will go over like everything you need to, like what connections you need to make in order to get this to work. So, yeah. Anyway, here's like a better angle on the whole thing. So, yeah. Anyway, yeah, so I want to do a video. Well, so I want to do videos like investigating different power delivery configurations for this thing. And also, I'm going to be messing around with like adding extra capacitors, that kind of thing, to improve the voltage regulation just generally. Um, but the other thing I want to do is do want to basically make a guide for like the electrical configuration of one of these 7970 power boards. And I'm just going to turn this off at this point. And yeah, that's kind of it. Also, one day I want to run this card on LN2. Yeah, it's like the end goal. And also, ideally, move the power board to the back, because that would be really cool if I could have it on the back and then use the stock heatsink. Because this looks, well, this kind of sucks in terms of actually cooling the GPU. Let's be completely honest, right? Like this thing was hitting what 60 degrees, and we weren't even doing sustained load. So yeah. Anyway, that's it for this video. So hopefully you found this somewhat entertaining, because, I don't know, it's not really all that practical. Unless you have a 1070 FTW and like a spare 7970 that, like, unless you have like a dead 1070 FTW or 1080 FTW and a 7970 reference, because again, like there's some cards where you cut the VRM and it doesn't want to turn on for no apparent reason, and then there's other cards where you cut the VRM, everything works. This is one of those cards where you cut the VRM, everything works. And well, there's one little thing that you need to do, but that's why I want to make a video about how to actually build a power board like this, out of 7970s. Especially since this model of 7970 is relatively common, and you can find them like for parts with typically dead 7970s will have like BGA damage, so it'll be like you need a new core or you need new memory chips or something like that. And yeah, in that case, like they're a relatively cheap source of like a good solid VRM potentially. So yeah. Anyway, so that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store, where I've recently added some new hoodie designs. So if you want a like AHOC hoodie, those are now up on the Teespring store. There's a link to that down in the description below. And then there's also my Bandcamp, where I've recently posted some new music. Though calling it music is giving me way too much credit. So anyway, yeah, that's it. If you'd like to support the channel, links in the description. Thanks for watching, and goodbye.